happen. So based on that, what we have here for the first side, the clockwise, this is anti-clockwise and this is clockwise. The anti-clockwise moment, we have all the sum of the moments here. We have 20 times 40 meter plus 20 times x is equal to 50 times what? 70. So we have 50 times 70. What we have here for the clockwise, we have 3,500. Then this other one, 20 times 40, we have 800 plus 20x. So what are we doing next? To get the value of this x we'll subtract 800 from both sides. If we subtract 800 from both sides, what we'll have will be 800 going out of here. We have 0 there, equal to today we'll be looking at moments. That is principle of moments. Principle of moments, and we'll be talking about moments. And by the end of this class, we'll be able to know how to do some calculation that has to do with this very topic. The first thing we're going to be talking about here is what is moment? What is moment? Moment of a force. Moment of a force about a point is a turning effect of the force about that point. Now, for example, if you have a force acting on, let's say I have that like this thing now, this is my marker. If a force is acting on it, it tends to make it move to a certain direction. For example, if I apply a load here, you find out that this object, this my marker, tends to be going down. This idea of going down, that turning effect it's producing, is what we consider as the moment of that force. And this moment, whenever we want to look at it or consider it, we'll consider the distance. We'll look at the distance of the line of action. That is why we say that it's the product is a product of the force and the perpendicular distance of each line of action from that point. For example, a force is applied here, and I apply a force here. The force will be pulling it down. As it's pulling it down, then we consider the distance from this from this force. So that is how we calculate this moment. Is a product, that is multiplication. Has to do with multiplication of that force and its perpendicular distance. Now, whenever we consider this moment, we consider it in two ways. That is, normally it's either clockwise or anti-clockwise. It's either clockwise or anti-clockwise. That's how we normally talk about it. So in dealing with moments, we look at it in that way. Now, what do we mean by clockwise? Now, if you look at your normal clock, let's say in your clock we have, this is 12, this is 3, this is 6, and this is what? This should be 9. So our clock, clockwise, means our clock normally moves this direction. So anything that's moved this direction now, as our clock is turning, just like I have this thing, as it's turning this way, it means that it's what? Clockwise direction. We're moving in clockwise direction like this. Moving that way is what? Clockwise. And we also look at it again in what? Anti-clockwise direction. Anti-clockwise is the one that's moving against the time the normal clock is going. While the clock moves this direction, the anti-clockwise goes against it, moves against it. That is the one we call what? Anti-clockwise. clockwise direction. Now, having known this, now we talk about this principle of moment. According to principle of moment, it states that principle of moment states that if a body is at equilibrium, then the sum of the clockwise moments about any point on the body is equal to the sum of the anti-clockwise moments about the same point when it's at equilibrium. When it's at equilibrium, means that the body balances. Then let's look at it. Remember, we said that this one is clockwise, another one is anti-clockwise, and we say we have a body. The body that balance. This is balanced now at equilibrium. It means that the sum of anti-clockwise is equal to what? The sum of what? Clockwise. For this object to balance, according to the principle of moments, these clockwise moments, all of them here has to balance with what? The anti-clockwise. They must be equal. Once they are equal, the object will balance, the body will balance in anywhere at that point, to balance at any of those points. Once they are at equilibrium. Now, having known this thing, we need to try some simple questions. Like I said, we're going to try some simple questions. This is just the beginning of this. By the time we go ahead, you find out that we'll be looking at some complex one. But now I want to start off with simple one that will encourage you to look, dig deeper, into the actual topic. So let's look at it. We know that some of the clockwise and some of the anti-clockwise must be equal for a body to be an equilibrium. So let's look at some questions that will help us understand this thing, know how to apply it effectively. So we'll be looking at these few questions here. I said that find the value of s. We have the s. This is the s that you are going to find the value, and the other one is the x also that we're going to be finding the value. Now, knowing that the moment of a force, what it really means, like we already established, that is the product of what? Product of force and its perpendicular distance. So what it simply means here is that since it's force, product of force and its perpendicular distance, it simply means that the unit, it means that the unit of each moment will be what? Force times distance, and distance is always in a meter, then force is in Newton, which means that our unit will be what? Newton meter. So principle of moment has already told us that they must be what? Moment of anti-clockwise moments must be equal to what? Clockwise moments. So based on that, we look at this, what we have here. From this first one, to solve the first one, the distance, perpendicular distance from the line of force or action, we have 10 times 60. This one is what? The anti-clockwise. Remember, this one is what? And clockwise, because it's moving to the direction of this is anti-clockwise. The principle of moment says that they are going to be equal. That is equal to what? 30 times what? Our x. 30 times x will give us 30x, while this will give us 600 Newton meter. So now to get the value of x will be 30x divided by. So what we have here will be, this will cancel out. We have what? X. S is this one and that one. This will then cancel out this. What we have will be that will be 20, means 20 Newton. 20 Newton, that is the value of this very well. We have found the value of x here. See how easy it is. So let's look at the next one. The next one we have here. So this one we are going to be looking at. If you look at this very well, find out the distance. We're finding the force, this force here. Look at the distance, 20. The other one is what, 40. From this perpendicular distance, we have it. So this other one is 70 and we have 50 here. So to get this from this point to that point, we have 50 meters and we have a force of what? 70 Newton. So to solve this problem, let's see how we're going to make it happen. So based on that, what we have here for the first side, the clockwise, this is anti-clockwise and this is clockwise. The anti-clockwise moment, we have all the sum of the moments here. We have 20 times 40 meter plus 20 times x is equal to 50 times what? 70. So we have 50 times 70. What we have here for the clockwise, we have 3,500. Then this other one, 20 times 40, we have 800 plus 20x. So what are we doing next? To get the value of this x will then be, we'll subtract 800 from both sides. If we subtract 800 from both sides, what we'll have will be 800 going out of here. We have 0 there, equal to 3,500 minus 800. So if we subtract the same thing here, 35 minus 800, we have, what we have will be 2,700 equals to 20x. So now x will then be over what? Over 20. Divided by 20. So our x will then be equal to 135 Newton. That's very big. That's very big. So that's our last answer. So what we have here, you can see how we solve it by, we add up all this together, all the anti-clockwise moments together that we did here, then we'll bring up this and get the value of whatever we are looking for. So this is where we're going to be ending this class for today. And then remember what the principle of moment says that the sum of the moment, when the body is at equilibrium, the sum of the anti-clockwise moments at that point must be equal to what? Sum of the clockwise moments at the same point. So another one we should also note is that the moment of a force at any point is a turning effect of that force at that point. The turning effect, remember this is noted very well, and to do the calculation is just a simple thing that, as we have seen from here. And thank you for coming this far, and we want to encourage you, if you are joining us for the first time, to subscribe to our channel. And if you have any question, you can drop it in the comment section. We'll always attend to you. And then remember to share and like. Thank you.